Photosynthesis by Sebastian, Max, and Ridge.
Here we have a chloroplast, and we will be naming the structures. Each individual circle of green is known as a thylakoid. Within the thylakoid is the thylakoid space, which the electron transport chain takes place. Outside of the thylakoid is the stroma, which there is proton gradient and the Calvin cycle. Then you also have the inner membrane and the outer membrane. Within those two, you have the intermembrane space, and then a segment of 3 thylakoids or more is known as a granum.
This chemical equation summarizes the reactants and products of the photosynthesis pathway. The equation shows that carbon dioxide and water are used with light energy to produce glucose sugar and oxygen gas.
Redox reactions take place in the electron transport chain from photosystem 2 to photosystem 1. As the electrons are being passed on from photosystem 2 to photosystem 1, photosystem 2 is losing the electrons or being oxidized, whereas photosystem 1 is gaining the electrons or being reduced.
Light reactions use solar energy, mainly red and blue wavelengths, to make ATP and NADPH, which supply chemical energy and reducing power to the Calvin cycle. The Calvin cycle incorporates CO2 into organic molecules, which are converted into sugar.
In the photosystem, a photon of light or light energy will hit a pigment molecule in the green as the green dots, and this will then transfer that light energy to a special pair of chlorophyll A molecules, which are in the reaction center complex. This transfer of energy in the electrons is then sent into the reaction center complex of the light harvesting complex, which in this case is photosystem 2 and photosystem 1. These electrons, through redox reactions, are then transferred from photosystem 2 through the cytochrome complex, which those electrons create ATP out of that and continue to be moved through redox reactions to photosystem 1, where more light energizes the pigment molecules to re-energize the electrons in the chlorophyll B molecules this time. They are also transported by electron carriers in PQ PC, and FD. In the final stage with NADP plus reductase, NADPH is created.
Non-cyclic electron flow uses PS2 and PS1, photosystem 2 and photosystem 1. Photosystem 2 supplies electrons to the beginning of the electron transport chain. When photosystem 2 loses an electron, or when it's oxidized, it is able to pull electrons from water. In contrast, photosystem 1 energizes electrons with a second input of light energy, so they have enough energy to reduce NADP+. Cyclic electron flow, electrons from photosystem 1 are redirected from ferredoxin back into the electron transport chain, prevents reduction of NADP+, produces only ATP. Mitochondria is the powerhouse of an animal cell. Chloroplast is the powerhouse of a plant cell. Some similarities are the electron transport chain. They both have redox reactions, and they both have ATP synthase. Some differences are mitochondria, in the beginning of the electron transport chain, mitochondria takes energy from organic molecules. Chloroplasts, in the beginning of electron transport chain, takes energy from H2O. The last difference is the movement of protons through the proton pump. Phase 1, carbon fixation. A CO2 molecule combines with a 5-carbon acceptor molecule, ribulose 1,5-bisphosphate. This step makes a 6-carbon compound that splits into 2 molecules of a 3-carbon compound. Phase 2, reduction. In the second stage, ATP and NADPH are used to convert the 3 PGA molecules into molecules of a 3-carbon sugar, glyceraldehyde 3-phosphate. Phase 3, regeneration. Some G3P molecules go to make glucose, while others must be recycled to regenerate the bisphosphate acceptor. Regeneration requires ATP and involves a complex network of reactions.